Good day, students. For today's lecture, we're going to talk about gas laws. This will be the final lecture on our general chemistry class for this semester. So please ensure that before watching this video, you've watched the two previous pre-recorded lectures. So that will be balancing of reactions and then the different type of chemical reactions. So before we even start, let us establish some known fact about gas. So alam natin na yung pag-uusapan natin today ay all about gases. So when we say gas, ano ba yung mga typical na alam natin about gas? 'Di ba? Alam natin na yung gas in a container, no? Sa isang container, meron tayong mga particles doon, no? Let's say for example, this container contains that gas. The atoms or the gas molecules itself moves in random motion. So that is one of the main properties of gas, no? So gumagalaw sila in random motion. Additionally, another known fact about gases is that the gas molecules do not interact with each other. So that is like the common thing we know about gases, no? Ngayon, let us establish some things na magagamit natin throughout our lecture in this particular topic. So first, let's talk about pressure. Okay, so pressure will be represented by letter P. So when we say pressure, in relation to gases, it simply means is how often do they hit the sides. So meaning, kunwari may container ka, no? Palitan natin yung kulay. Pag sinabi nating pressure, is gaano sila tumatama sa gilid or boundary ng container kung anong kinalalagyan nila. So meaning, the more na mas bumabangga sila sa sides ng isang container or dun sa mismong walls ng container natin, ang ibig sabihin lang nun ay mas mataas yung pressure niya. So that is how we relate pressure to gas molecules. So ulitin ko ha, pressure is how often do they hit the sides. Now, after pressure, let's talk about what is temperature. So temperature in relation to our gas molecules talks about the movement of the gases, no? So, how fast do the particles move? So, the more na mas mabilis silang gumagalaw, no? It means mas mataas yung temperature nun. Okay, so yun yung relationship ng temperature sa gas molecules natin. So, temperature talks about the movement or the speed of the gas molecules, while pressure talks about how often do they hit the sides. Now, after pressure and temperature, we also have what we call volume. So when we talk about volume, which is represented by letter V, yung volume in relation to our gas is actually not directly related to the gas molecules. So volume relates to the container where the gas molecules can be found. So for example, ito yung container A natin, no? Ito yung container A natin versus ito yung container B natin, no? And imagine natin na within the container may mga gases tayo. Pero it's not about kung gaano kadami yung gas molecules natin. Yung also, ganun din yung pwede nating ma-relate to volume. Instead, when we talk about volume, it is how big the container is. So, kung titignan natin yung size between container A and container B, alam natin na mas malaki yung container A. So, because of that, it has a higher volume than container B. So, yun yung tatlong tatandaan natin na factors that will contribute in helping us to understand our lecture for today. So first, we have pressure, which talks about how often do they hit the sides. Gaano sila daming beses tumatama sa walls or gilid ng container natin. While when we talk about temperature, how fast do the particles move? Gaano kabilis gumagalaw yung gas molecules natin? While for volume naman, it is directly related to the container itself. Gaano kalaki or gaano kaliit yung container na pinaglalagyan ng gas molecules. So those are the few things na need muna natin ma-establish before we start defining or teaching some of the gas laws na meron tayo sa lecture na to. Okay. So first, we talk about Boyle's law. Okay. So Boyle's law is at constant temperature. So nangyayari daw yung Boyle's law at constant temperature. So, isa ito sa condition na dapat natin tatandaan. Okay. So, Boyle's law at constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the applied external pressure. So, yun yung ibig sabihin daw ng Boyle's law, na yung volume occupied by a fixed amount of gas is inversely proportional to the applied external pressure. Anong ibig sabihin nun, sir? Ano pong ibig sabihin ng inversely proportional? Okay, so tingnan muna natin yung figure natin dito, no? So, tatandaan natin na this is in relation, this particular law or this Boyle's law happens under constant pressure. So, ang tinitignan natin dito for Boyle's law are both the volume and pressure. Okay, so mali si sir. Hindi constant pressure but instead constant temperature. Yun naman nakasulat sa taas. Ulitin lang ni sir ha. So Boyle's law is under constant temperature. Okay. So imagine nyo, ito yung original form natin. Kung mapapansin nyo, meron tayo ditong piston. So imagine nyo, yan yung itong piston na to is umaangat yan at bumababa. Yun yung purpose niya. Imagine nyo siya na parang siya yung nasa injection, no? Pag tinulak mo yung injection, mas lumalapit yung parang nagtutulak dun sa liquid na nasa loob ng injection. While pag hinila mo naman yung parang pump nung injection natin, no, parang lumalayo yung tumutulak dun sa liquid natin. So ganun din yung purpose ng piston na to. So again, please take note that Boyle's law happen at constant temperature. So, ang tinitingnan natin dito ay volume and pressure or vice versa, pressure and volume. So, ngayon, kung mapapansin nyo dito, na pag nag-decrease yung volume natin, mapapansin nyo, no, yung piston natin gumalaw. So, dito yung original niya at dito sa kabila, napansin natin na bumaba yung piston natin. So, anong indication ng pagbaba ng piston natin? Ang indication nun is bumaba yung volume natin kasi lumiit yung space kung saan pwede gumalaw yung gas molecules natin. Pero ang indication ng mas maliit kasi na space is mas maraming beses na pwedeng tumama yung gas molecules natin sa sides ng container natin. And because of that, we can conclude that when the volume decreases, the pressure also increases. Yun yung nangyari dito sa circumstance natin dito. Again, bakit bumaba yung volume? It's because bumaba rin yung piston natin. 'Di ba? At first, ito yung space na meron tayo. Kung papansin nyo, ito yung space na meron tayo. But after some time, lumiit siya. So because of that, bumaba yung volume natin. Anong indication ng pagbaba ng volume? Once na bumaba yung volume natin, mapapansin natin na dahil lumiit yung space na meron yung gas molecules natin, mas napapadami yung pagtama nila sa gilid ng container natin. Because please take note that pressure in relation to our gas is how answers the question, how often do they hit the sides? So, the more na mas maraming beses tumatama sa gilid ng container yung gas molecules natin, the more na mas mataas yung pressure niya. Okay? Now, ano namang indication pag tinaasan natin yung volume? Okay. So, kung mapapansin nyo, ito yung original piston natin, no? Ito yung meron lang tayo na na volume, and then as you can see on the right side, inangat natin yung piston natin, and because of that, anong mapapansin natin dito? Lumaki yung space na pwedeng pwedeng galawan ng ating gas molecules. So because of this, napansin natin na meron tayong increase in volume. Ngayon na nag-increase yung volume natin, mas lumuwag yung space kung saan pwedeng gumalaw yung container. Ang possibility nito is that mas magiging less yung possibility na tatama yung gas molecules natin sa gilid ng container natin. Because kung mapapansin nyo, mas malawak to, di ba? Mas malawak to. So dahil mas malawak to, there are some instances na hindi na ganun sila tatama sa gilid ng container natin. And because of that, we can say that when there's increase in volume, there will be decrease in pressure. Or mas kokonte yung pagtama ng gas molecules natin sa side ng container. So, here, in Boyle's law, it simply explains that yung relationship ng volume and pressure ay inverse. So, sir, when we say inverse, ano po ibig sabihin nun? When you say inverse, ang ibig po sabihin nun ay pag tumaas yung isa, bababa yung isa. Kaya nga inverse magkaiba, opposite. So again, pag sinabi nating inverse, it's an opposite. So yung relationship ng pressure to volume is inverse. So pag tumaas yung volume, bababa yung pressure. Pag bumaba yung pressure, tataas yung volume natin. And it can and everything that we've discussed can be summarized by this formula. Please take note that pressure initial multiplied by volume initial is equal to pressure final multiplied by volume final. So P is for pressure, V is for volume, and then when we say initial, yun yung meron ka at the start, and when you say final, that is your last, or kumbaga yun yung final, kung tawagin natin, yung dulo na state nung pressure and final natin. But please take note that we can also represent initial as 1, no? Pwede nating sabihin na initial is also 1, and then pwede nating sabihin na yung final yun yung 2. Meaning yung initial siya yung nauna, while final as yung huli. So we can rewrite this equation as simply as P1 V1 is equal to P2 V2. So ito rin yung pwede nating gamiting formula. Okay, so that is our Charles law. Boyle's law pala. Okay, pasensya na, no? If ever man na nabanggit ko siya as Charles law, hindi po siya Charles law, instead it is Boyle's law po. Okay? So, nagkakamali lamang po tayo. Ngayon, let's talk about Charles law. So, ito na yung Charles law. Basahin natin. Charles law, at constant pressure, the volume occupied by a fixed amount of gas is directly proportional to its absolute Kelvin temperature. So, ano pong pinupertain ng Charles law? So, please take note that Charles law happens, no? Nangyayari ang Charles law at constant pressure. So, ang tinitignan natin sa Charles law ay yung relationship ng volume and temperature. At sinabi dito na yung relationship daw ng pressure, yung relationship ng temperature and volume po natin ay directly proportional. So, volume, wag tayong gagamit ng yellow, medyo malabo. Okay. So, yung relationship daw ng volume is to temperature is directly proportional. So, ipapakita natin yon. Paano ba nangyayari dito? Okay. So, tatandaan natin na ang tinitingnan nating factor for Charles law ay yung sa temperature and volume. And at the same time, no, tatandaan natin na under Charles law, constant yung pressure natin. Pag sinabi natin constant, hindi po siya gumagalaw, diba? The same lang siya. So, ang titignan natin dito, meron ulit tayong container na may piston. So, in this condition, no, parang normal, at this condition, wala pa tayong binabago with regards to temperature and volume. Pero kung mapapansin natin dito, na as we lower the temperature, okay, pag linower daw natin yung temperature, anong mangyayari? The lower the temperature, the volume also decreases. Okay, so pag mas mababa daw yung temperature natin, mas liliit daw yung volume natin. While pag tumaas naman yung temperature natin, so imagine nyo yun, no? Tumaas yung temperature natin, anong mangyayari? Tataas din daw yung volume natin. Okay, in this particular figure, no, hindi ganun ka-obvious kung paano nag-work yung Charles law. Okay? But eventually, ang pinaka tatandaan lang natin for Charles law is pag nagtumaas yung isa, tataas din yung isa. That's the reason why their relationship is directly proportional. So, yun yung tatandaan natin. Okay? So, here is the formula for your Charles law. No? Volume initial over temperature initial is equal to volume final over temperature final. Okay, so to rewrite that, we can write that as V1 over T1 is equal to V2 over T2. Or pwede pa natin tong i-rewrite into V1 T2 is equal to V2 T1. So kung mapapansin nyo, ang ginawa lang natin is nag-cross multiply tayo, no? Okay. So either ito gagamitin nyo or ito, it doesn't matter. Okay. So that is your Charles law. Now, let's move on to Gay-Lussac's law, no? So dito na yung pangatlo natin na gas law. So for Gay-Lussac's law, ang constant naman dito ay ang ating volume. So this happens at constant volume. So the factor that we're looking at right now would be your pressure and your temperature. Okay, so pressure and temperature po yung tinitignan natin. Okay? So, etong Gay-Lussac's law, pinakamagandang example na to in real life is what happens in a pressure cooker. So, 'di ba pag nagluluto tayo ng mga matitigas na karne, no, or matitigas na pagkain, gumagamit tayo ng pressure cooker. So, mapapansin nyo, syempre yung pressure cooker nyo, pagpasensya nyo na si Sir, hindi maganda yung drawing niya. Okay. So, syempre yung pressure cooker, alam naman natin hindi naman nag-expand yan. So, technically, constant yung volume niyan. Hindi nagbabago yung container natin. But of course, if there's an increase in temperature, di ba, syempre, papainitin mo, this is your fire. No? Ang mangyayari sa loob is, of course, nagkakaroon ng mas mabilis na paggalaw yung ating gas molecules. Dahil mas mabilis din yung galaw nila, mas mataas din yung chances na mas marami silang matamaan na sides ng ating container, or mas marami yung beses sa pagtama nila sa sides ng container natin. So yun yung ine-explain dito ng Gay-Lussac's law, na yung relationship ng pressure and temperature is directly proportional. So same as our interpretation for Charles law, pag sinabi nating directly proportional, ang ibig sabihin lang po nito ay pag tumaas yung isa, tataas din yung isa. So pag tumaas yung pressure, no? Pag tumaas yung pressure, tataas din yung temperature. Pag bumaba yung pressure, bababa rin yung temperature. Okay, so mapapansin nyo dito, di ba, nag-constant yung volume natin. So the reason why na mas marami lang na beses na tumatama yung gas molecules natin sa side ng ating container, it's for the reason that mas mabilis yung galaw nila because of increase in temperature. And then, dahil naman mas mababa yung pressure natin pag binaba yung temperature, it's because pag bababa yung temperature natin, yung movement din po ng gas molecules natin would be very slow, and because of that, no, mas mababa yung probability na tatama yung gas molecules natin sa sides ng container natin. So again, yung relationship ng pressure and temperature for Gay-Lussac's law is directly proportional. Okay, so the formula for Gay-Lussac's law is this, but we can also rewrite that as P1 over T1 is equal to P2 over T2. So pag gusto nyo linear siya, cross-multiply lang ninyo, no? So it could also look like this, no? P1 T2 is equal to P2 T1. Okay, so ito po yung tatlo so far natin na gas laws. While for the fourth one, this is your combined gas law. So for combined gas law, ang kinonsider na natin dito is that ang kinonsider na natin dito ay yung 3 variables natin instead of 2. So this is actually the combination of Boyle's law with regards to constant temperature, tapos pressure at volume lang yung tinitignan, and Charles law with respect na ang tinitignan natin lang doon ay yung volume at temperature kung saan constant yung pressure natin. So because of that, instead of having 2 variables lang for the combined gas laws, no, we are looking at 3 variables, which is your volume, pressure, and temperature. So this is your final formula for the combined gas law, no. So we can rewrite that as P1 V1 T1 equal to P2 V2 T2. Okay? Kung gusto nyong linear, i-cross multiply lang natin. So this will be P1 V1 T2. This will also be P2 V2 T1, or pressure initial, volume initial, temperature final, P2 final, volume final, and your temperature initial. Something to take note pala na hindi ko na mention starting from Charles law is that the temperature should always be in Kelvin scale. Okay? So for temperature, lagi po dapat siyang naka-Kelvin. So pag nakita po natin na yung given po na variable or given po na value is in Celsius or Fahrenheit, we convert those unit into Kelvin. But madalas naman ang binibigay naman natin na unit is degrees Celsius. So how do we convert degrees Celsius to Kelvin? Very simple. We just simply add 273.15. Please take note of the 15. That is very important, no? So again, the temperature unit that we're going to use for the different gas laws will always have to be Kelvin. Pag naka-Celsius siya or Fahrenheit, we convert it into Kelvin. Pag Kelvin na siya, no need to convert. Now, the question would be, sir, how about the other variables? How about volume, sir? How about pressure, sir? So, to answer that question, it doesn't matter kung ano po yung unit ng pressure and volume. So, pag pressure, pwede siyang maging bar, atmosphere, or mmHg, pwede po siyang ganon. It doesn't matter. As long as parehas po yung unit ng pressure 1 and pressure 2 mo, okay lang. Kunwari sa volume, given ml, or given ml. Tapos sa ibang tanong, given liter. Sa ibang tanong, given ounces. Sir, ano po yung volume na gagamitin natin? To answer that question, again, it doesn't matter. As long as parehas yung unit ng pressure 1 and pressure 2, goods po tayo doon. Ang only time na papakilaman lang natin ang unit is titignan po natin kung naka-Kelvin si temperature. Pag hindi po natin kinonvert si temperature into Kelvin, automatically mali na po yung sagot natin. Okay? Other units, wala po tayong pake. Okay? So, on that note, kailangan din natin magsagot ng tanong. Okay? So, feel free to pause. No? Feel free to pause kung anong gas law formula yung gagamitin natin. So tatlo lang naman yun, 'di ba? We have your Boyle's law, okay? And then the other one is your Charles law. You also have your Gay-Lussac's law, no? So ano kayang formula yung gagamitin natin? Okay? So feel free to pause. O basahin muna natin. An inflated helium balloon with a volume of 0.55 liter at sea level, 1 atmosphere, is allowed to rise to a height of 6.5 kilometer, where the pressure is about 0.40 atmosphere. Assuming the temperature remains constant, what is the final volume of the balloon? Okay. So, feel free to pause, ha? Okay. So, in this particular question, ang best way natin para malaman kung anong formula yung gagamitin natin is to look at the given. So, may binigay tayong volume. Very obvious siya. Okay. So, obviously, ito rin yung volume initial. Ito, binigay din yung pressure dito. So, this is pressure initial. And then, along the line, meron kang binigay na height, which alam natin it doesn't matter kasi gas laws are not affected by height. So, baka ma-overwhelm kayo, no? Uy, may height, pero yung tinuro ni sir, wala. So, because of that, tatandaan lang natin, hindi natin isasama yon. Pero alam natin na ito yung initial natin na volume and ito yung initial natin temperature. But as time goes by, sabi daw na tumaas daw yung pressure natin, bumaba yung pressure natin into this. Okay, so technically, this is P2. Tapos, based sa tanong, ang hinahanap ay final volume or your V2. So, technically, ang formula na gagamitin natin dito ay your, this would be your Boyle's law. Okay, so yung relationship to ng pressure and volume. So, here is your formula for Boyle's law. But then again, kanina, nilabel na natin kung sino yung pressure 1, volume 1, pressure 2, and volume 2. So, because of that, i-input na natin yung mga given dito sa tanong dito sa formula. And we'll have these values, diba? So, this is your pressure 1 atmosphere. This is your volume 1 or volume initial, 0.55 liters. This is your pressure final, 0.40 atmosphere. And this is your volume final, which is the one that is missing. So in order for us to calculate volume final, we need to derive the formula. So in order to derive this, we need to isolate volume final. So how are we going to do this? So meron tayong 0.40 dito na kasama ni volume final. In order para si volume final na lang yun nandito, is we need to divide both sides by 0.40. So 0.40, and then here is 0.40 then. So our final formula would be V final is equal to 1 atmosphere. Okay, 1 atmosphere times 0.55, and then that would be over by 0.40. And from there, we can find VF or V2. Okay, so on that note, we can solve na for V2. And ang final natin na sagot ay 1.38. So ipakita rin natin kung paano natin na-solve. So that is 1 times 0.55 over 0.40. So with that, we have this answer, no? 1.38. Okay, so always round off your values into 2 decimal places or depende sa hinihingi ng tanong. Okay? Next, we have our second question here. So, babasahin yung ulit ni sir. A sample of chlorine gas occupies a volume of 946 milliliters at a pressure of 726 mmHg. Calculate the pressure of the gas in mmHg if the volume is reduced at constant temperature to 154 ml. So, kung mapapansin nyo, binigyan tayo dito ng, ano mga binigay dito? Meron tayong volume. So, technically, this will be your volume 1 at a pressure of 726 mmHg. So, this is pressure. And technically, kung mababasa nyo yung tanong, it's also your pressure 1, no? Okay. After that, we have our naka-ml ulit siya. So, may volume ka na nabawasan daw, or from the original volume natin nabawasan daw siya. That's why we have 154 ml. And because of that, no, this will be our V2. So, ito pala yung volume natin na nauna, no? So, from 946 ml, naging 154 siya. So, technically, this is your initial, this is your final. Okay. So, in this case, ang meron tayo ay, volume and pressure. So, technically, this is also an example of Boyle's Law, no? Ang application natin dito ay Boyle's Law. Okay. So, tingnan natin. Okay, very good. So, this is the formula for Boyle's Law. Sa taas, we've already labeled, no, kung ano yung pressure 1, pressure 2, volume initial, and then, in this problem kasi ang hinahanap natin is, ang hinahanap pala natin dito ay pressure final. So, binigay na kanina yung pressure initial, volume initial, and then your volume final. So, in that case, we can input all these values. Again, in order to solve this, we need to isolate pressure final because it's the one that is missing. So because of that, we just simply have to divide both sides with 154 ml kasi yun yung kasama ni pressure final dito sa equation. So ang gusto kasi natin ay solo lang niya dito sa gilid. So cancel to. So ang final natin na formula ay P2 is equal to 726 mmHg multiplied by 946 ml over 154 ml. So that is our final solution, no? So solve natin. So we have 726 times 946 over 154. So ang sagot natin dito ay 4,459.72. So tingnan natin kung tama. 0.71 pala. Okay, so mapapansin nyo, tama yung final answer natin sa kinalculate natin. So you can see, very straightforward lang siya, no? The only possible difficulty of this type of question is that hindi natin alam yung formula na gagamitin natin. But the best way to determine the formula is to base it on the given. And then, we interpret from the given kung sino yung initial, sino yung final, no? Okay. On that note, let's move on to our third question. So for our third question, let me read it again. Argon is an inert gas used in light bulbs to retard the vaporization of the tungsten filament. A certain light bulb containing argon at 1.20 atmosphere and 18 degrees Celsius is heated to 85 degrees Celsius at constant volume. Calculate the final pressure. So technically, ang hinahanap daw natin ay final pressure. Okay, so let's look at the given. We were given by 1.20 as an initial pressure, and please take note that nawawala yung P2 natin. And then the other given are 18 degrees Celsius, which the unit itself tells us that this is your temperature. Anong klaseng temperature? Because this is your P1, this will also be your T1. And then 85 will be our temperature too. But please take note that because our temperature is in degrees Celsius, we need to convert both of them into Kelvin. But before we convert it, let's look at the problem first and determine kung anong formula yung gagamitin natin. So this formula, my pressure at temperature, this will simply be your Gay-Lussac's law, Okay, so this is your Gay-Lussac's law. Kung saan yung relationship between temperature and pressure are directly proportional. So, let's convert T1 first. So, T1 is equal to 18 plus 273.15 para maging Kelvin. And then, for T2 naman, that is simply 85 plus 273.15. Okay, so, yun yung solve natin dito. So, 18 plus 273.15, that is equivalent to 291.15. So, palitan lang natin ng kulay yung natin, pen. So, that is 291. Okay? 91.15. Kelvin na siya. Okay? Kasi na-convert na natin. And then, the next one will be 85 plus 273.15. And that will be 358.15. So, etong converted natin na temperature yung gagamitin natin na i-input natin for Gay-Lussac's law. So, on the next slide, mapapansin natin na ito yung formula natin for Gay-Lussac's law. And technically, ito yung values na natin. So, mapapansin nyo, yung temperature na natin ay naka-Kelvin scale na, which we converted earlier. Okay? So, from there, paano natin isosolve si P final or pressure 2? So technically, in order to isolate this, we just have to simply cross-multiply the denominator, then isolate it. So technically, in doing that, ang gagawin na lang natin dyan ay that will be 1.20 atmosphere times 358.15. Tapos, nasa kabila si P2, pero i-divide na natin si 291.15 Kelvin. Okay? So, ito na siya, Okay, so paano natin ginawa yan? P1 over T1 is equal to P2 over T2. T1 to ha, T1, and then this is P2 over T2. So that's P1 T2 over equal P2 T1. So dahil nawawala si P final or our P2, we need to isolate it. So divide both sides by T1. So cancel to. So our new formula for P2 is equal to P1 T2 over T1. Okay, so in solving that, solve na natin. So that is 1.20 times 358.15. Please take note that the parenthesis is the same as the multiplication sign. So 291.15. So the answer in this question is 1.48 kasi i-round off natin into 2 decimal places. So this is your answer for question number 3. Okay. So again, balikan ninyo na lang yung way natin ng pagko-convert. Overall, so far, hopefully, okay pa kayo. Okay, meron pa tayong dalawang question. So, next question, basahin natin. A small bubble rises from the bottom of a lake where the temperature and pressure are 8 degrees Celsius and 6.4 atmosphere to the water surface, where the temperature is 25 degrees Celsius and the pressure is 1 atmosphere. Calculate the final volume in milliliters of the bubble if its initial volume was 2.1 milliliters. So in this case, ang hinahanap po natin is V2. So V2 ay yung nawawala. Tignan natin yung given. So ang given natin ay meron tayong T1, meron tayong P1, no? Then meron tayong T2, and then meron tayong P2. And then finally meron tayong V1. Okay, bakit natin to nasabing V1? Kasi sabi niya, calculate the final volume. So nawawala yung final volume of the bubble if its initial volume is 2.1 milliliters. Okay? So in this case, mapapansin nyo, tatlo yung variable natin. May pressure, volume, and temperature tayo. So because of that, we expect to use the formula na combined gas law. Okay. So mapapansin din natin, yung temperature po natin ay naka degrees Celsius, so we need to convert it. So T1 is simply 8 plus 273.15, and then T2 is 25 plus 273.15. Okay, on that note, solve natin. 8 plus 273.15, that will be equal to 281.15. And then 25 plus 273.15 is simply 298.15. So this is the volume that we're going to use for solving the final volume or volume 2 sa problem na to. Okay? On that note, kung papansin nyo, ang ginamit nating formula ay combined gas law. So the combined gas law ay yung mixture ng formula ni Boyle's and Charles law. Okay? So, i-derive na natin dito, no? So, derive natin dito yung V final kasi alam natin na V final yung nawawala. So, cross-multiply natin. Cross-multiply natin. So, that will be P1, V1, T2 equal to P2, V2, T1. So, dahil nawawala yung V final, we need to remove P2 and T1. So, tanggalin natin. Divide both sides by P2 and T1. So, P2 and T1. So, the final formula will be V2 is equal to P1, V1, T2 over P2 and T1. Okay, ito yung gagamitin nating formula. And by incorporating all the values that we have in the problem or the given values from the problem, we'll have this. Again, i-rearrange lang natin tong mga to into this formula for us to calculate the final volume for the problem. Please take note as well that the temperature that should be used in this type of problem should be in Kelvin scale. So in that case, pag tinuloy pa natin, ito na yung na-arrange na formula. So, solve na natin. Alam ko binigay na yung sagot pero pinapakita pa rin sa inyo ni Sir kung paano i-solve. So that's 6.4 simply times 2.1 times 298.15 over 281.15 times 1. So the final answer will be 14.25. Okay? ml. So, paano natin nalaman na ml yan? Because cancel yung atmosphere dahil parehas sila, cancel yung Kelvin parehas dahil parehas sila, and then matitira tayong ml. Ganun din sa mga problem natin sa taas, no? So, sa problem natin sa taas, mapapansin po natin, anong mapapansin natin sa problem sa taas, na meron tayong atmosphere dito na natira kasi makakancel yung Kelvin at Kelvin, and yun din yung naging unit natin. And please take note, pag may make sense siya, kasi pressure yung hinahanap. So, dahil pressure yung hinahanap, we expect the unit to be in pressure. So, ganun din dito sa ibang problem natin sa taas, no? Na kung saan naman ang hinahanap naman ay, ang hinahanap naman ay pressure din. So, mapapansin nyo, makakancel both ml, matitira is mmHg. So, mmHg is a unit of pressure. And then for our first problem kanina, ang kinalculate naman natin at volume. So we expect that the unit for volume will be also, the final answer will have a unit in volume. So makakancel yung atmosphere, matitira yung liters. That's the reason why may liters tayo. Okay? Now let's move on to our final example. So this would be our final example. Basahin lang natin, no? So a gas initially at 4 liters, 1.2 atmosphere, and 66 degrees Celsius undergoes a change so that its final volume and temperature are 1.7 liters and 42 degrees Celsius. What is the final pressure? Assume the number of moles remains unchanged. So technically, very obvious na rin siya kasi tatlo yung variables natin. So this will be Gay-Lussac tuloy, sorry. This will be your combined gas law. So, paano natin nalaman na combined gas law based on the given? So, we have here volume 1. Paano nalaman ni sir na volume 1? Ito, sinabi, umpisa pa lang na initial. This is your pressure 1 and this is your temperature 1. And we have also here volume 2 and temperature 2. And the one that is missing is pressure 2. So, ang nawawala po sa tanong na to ay pressure 2. Again, look at the temperature. Both of the temperature is in degrees Celsius, so we need to convert it, no? So, T1 is simply 66 plus 273.15. And then we have T2, which is 42 degrees Celsius plus 273.15. So, solve lang natin, no? So, ko dito sa kabila. So, you have 66 plus 273.15. So that is simply 339.15. 339.15. And then the other one will be 42 plus 273.15. That will be 315.15. So, ito yung dalawa nating bagong temperature, no? Not bago, but rather this is the converted version of our temperature. So, yung Kelvin na unit yung gagamitin natin, or the Kelvin version of our temperature yung gagamitin natin. So, again, we're using the combined gas laws. So, ang nawawala po sa atin ay pressure final. So, let's convert everything or derive the pressure final formula, no? So, that will simply be cross multiply. So, that's P1 V1 T2 over not over, but rather equal to P2 V2 T1. So, nawawala yung P2. So, we need to remove V2 and T1. So, divide both sides by V2 and T1. Okay, or volume final and temperature initial. So, the final formula for pressure final is simply P1, or pressure initial, volume initial, then temperature final, over volume final, then temperature initial. Okay, so this will be the formula that we're going to use, no? So please take note, ito yung itsura niya by default, and mapapansin natin na yung temperature na ginamit natin is the converted version of our temperature given as degrees Celsius earlier. So this version is now their Kelvin form, or dinagdagan lang natin siya ng 273.15. So in order for us to derive the formula, we just have to apply the same process that I did above, no? And from there, we'll have this version, no, ng formula natin with the given values. And in order to check kung tamang ginawa natin, let us calculate it using our calculator here. So you have 1.2 atmosphere times 4 times 315.15 over 339.15 times 1.7. Okay? Please take note that what's missing in this particular problem is pressure final. So we expect that the unit for pressure final is also in a pressure unit. So because of that, tignan natin kung anong final sagot. Makikita natin that it is 2.62. So atmosphere yung unit ng pressure natin, or our pressure initial, so we expect it as atmosphere then sa pressure final. But here we eliminate liters because meron ka sa taas, meron ka sa baba, and we also eliminate Kelvin kasi meron ka rin sa taas and meron ka rin sa baba. And from there, we were able to get a unit of atmosphere. Okay? So that is how we apply the different So that is how we apply the different gas laws. So balikan lang natin ha. From the very start, okay, we defined what is gas, diba? Gas moves in random motion, no? And then they are very far away from each other. That's the reason why sabi ng mga scientists nung unang panahon, gas molecules do not interact. And then from there, we discuss Boyle's law, which states that at constant temperature, yung volume and pressure relationship natin would be inverse. Meaning, pag tumaas yung volume, bababa yung pressure. And vice versa. No? Pag tumaas yung pressure, pwede ring not pwede, but rather bababa yung volume. So, we have an inverse relationship between pressure and volume, and we use this formula, no? P initial multiplied by your V initial is equal to P final multiplied by V final. After that, we have Charles' law, which happens under constant pressure, kung saan sinabi na volume and temperature is directly proportional, meaning yung increase ng isa will always be the increase of the other variable. So pag tumaas si volume, tataas si temperature. Pag bumaba si temperature, bababa rin si volume. So it is represented by the formula V initial over temperature initial is equal to V final over T final. Okay? After that, we have Gay-Lussac's law, which happens under constant volume. So here, sinabi na yung relationship between pressure and temperature is directly proportional. This phenomena, ang best explanation nito is what happens in our pressure cooker kung saan may build-up ng pressure. No? And because of that, we are able to tenderize the meat. No? So, dito, sinasabi dito yung relationship ng volume, not volume but rather pressure and temperature ay directly proportional kung saan pag tumaas yung isa, tataas din yung isa. Pag bumaba yung isa, bababa din yung isa. And the relationship is represented by this formula. P initial over T initial is equal to P final over T final. And lastly, we have the gas laws, or rather our combined gas laws, kung saan pinagsama lang yung formula ni Boyle's and Charles' law and gave us three variables. So here we have volume, pressure, and temperature as our variables, no? And this is represented by this formula, which is P initial multiplied by your volume initial over T initial equal to P final multiplied by V final over T final. Please take note that initial can be represented by the number 1 as well, and final can be represented by the number 2 as well. And then sabi natin na pag pressure in relation to gas, that simply means that, or rather, it answered the question, how often do they hit the side? So, meaning, gaano sila kadalas tumama sa gilid ng container. While temperature, in relation to gas, is about its movement. Gaano kabilis ang paggalaw ng gas molecules. And volume is in direct relationship with the container. So, the bigger the container, the bigger the volume is. So, yun yung parang tinakil natin in this particular lecture. So, hopefully, naintindihan po natin. Napakasimple lang yung solving na ginagawa natin dito. The only problem na makikita ko na maging problema ninyo ay yung hindi po natin ma-identify yung formula na gagamitin or malito po tayo kung sino si initial and si final. Pero kung magpa-practice po tayo mabuti, especially meron tayong 5 tanong dito na pwede nating pag-practicean, no? Pwede po tayong matuto at maging eksperto sa paggamit po ng 4 na formula na binigay ni Sir sa lecture na to. Okay? So on that note, I would like to thank everyone for a very wonderful SEM, and hopefully sa mga mangyayaring assessments sa inyo, this P3 would be in your favor, no? May pasa nyo po sana sila lahat. Sa mga taong sa mga estudyante rather na umaasang maging cum laude, pagbutihin pa po natin para makamit po natin yung grade na gusto natin. Sa mga estudyanteng may hinahabol pang grade, pagbutihin po natin para pumasa po tayo. Lagi po natin tatandaan na kami dito sa CCJE family would always want you to stay here sa Finmayupang, no? College of Urdaneta. Okay? So pagbubutihan po natin lagi mag-aral. Maraming salamat po.